Hi, my name is Caitlin, and I work with the hardware team that developed the LumaField Neptune, our X-ray CT scanner. Today I'm going to introduce you to the scanner and walk you through setting up a scan. We designed the Neptune to be as easy to use as possible. It can integrate seamlessly into an office or workshop and doesn't require a dedicated space. The machine is approximately 6 feet wide by 6 feet tall and is just under 3 feet deep so that it can fit through a standard doorway. The scanner has leveling caster wheels to help move it into position during installation and then lock into place to ensure long-term stability. It runs on a standard 120 volt, 15 amp outlet and has both Ethernet and Wi-Fi connectivity. LumaField takes X-ray safety very seriously, and we design our products to keep both operators and bystanders safe from X-ray radiation. Before operating the scanner, you'll complete a brief safety training program. This video does not replace your formal safety training. Neptune meets or exceeds the most stringent requirements set forth by the US Food and Drug Administration, as well as regulators in each state and country where scanners are installed. The main chamber of the machine is surrounded by lead shielding to block stray X-rays. Each scanner is tested for X-ray safety before leaving our factory and after installation at a customer site. We use several hardware and software features to make sure that X-rays are only emitted when the door is closed and the machine is ready to operate. The X-ray status is indicated by the lights at the top right corner on the front of the machine. Green means that the X-rays are off, and red means that the X-rays are on. There's an emergency stop on the front of the scanner that will cut power to the X-ray source. There's also a lockout switch with a key that allows your company to manage access to the machine. One final note is that when the X-ray source is off, the scanner and everything inside it is completely safe. Objects don't develop radioactivity by being scanned, so they're safe to handle immediately. Now let's walk through how to set up and run your first CT scan. The scanner is operated by using a touchscreen interface. First, we can open the scanner by tapping the unlatch button at the top. Inside is the main scanning platform, which is where the objects are placed to be scanned. The X-ray source on the right will shoot X-rays through the object to the detector system on the left. Materials that are denser or thicker will block more X-rays than materials that are thinner or less dense. Throughout the duration of the scan, the scanning platform rotates 360 degrees so that the X-ray images can be captured from a variety of angles. The scanning platform can be manually jogged both horizontally and vertically. Moving the object towards the X-ray source will increase the magnification, but will result in a smaller scan volume. Moving the object away from the X-ray source will decrease the magnification and result in a larger scan volume. I like to think about this as if there's a light bulb on the right side of the machine shining onto the object and casting a shadow to the left side, where the detector is. If we move the object closer to the light bulb, it'll cast a larger shadow. As long as the part meets the recommended material thickness criteria for the scanner, you should be able to achieve a high-quality scan. Here are some considerations to keep in mind to maximize the quality of your scans. Let's start with fixturing. LumaField provides a versatile fixturing kit designed to accommodate diverse parts and provide flexibility in setup. Using our breadboard turntable, choose the smallest size that can support the part to allow for maximum magnification. You can use lollipops, angled foam fixtures, or floral foam for optimal part positioning. Make sure your part is fully secured and check for any movement before scanning to prevent scan artifacts. No matter how the part is fixtured, we'll want to minimize the distance that the X-rays have to travel through it at any given point during the scan. In the case of a monomaterial part, this typically means orienting the long axis to be approximately vertical. And if your part is multi-material, you want to orient the denser material to be approximately vertical. Take this wrench, for example. When I orient it, I won't position it to where the X-rays have to travel all the way through the long part of the wrench. Instead, I'll orient it so the long axis is again approximately vertical. If your part has flat surfaces, you'll want to make sure that they're not horizontal. If I were scanning a long cylinder, for example, instead of orienting it vertically, I would give it a 5 or 10 degree tilt. Both of these orientation tricks will help to reduce reconstruction artifacts. Once we've oriented and fixtured our part, we'll place it on the scanning platform. Be sure to center it on the platform since it's going to rotate throughout the duration of the scan. We also want to center the object vertically relative to the X-ray source by moving the slider to bring it into the field of view. In order to finish positioning the part in the field of view, we're going to visualize it with X-rays. We close the door and then press the button to turn the X-rays on. After making any necessary adjustments, we can hit Verify Bounds to take sample images of the object at different angles to make sure it's still within the frame. Next, we'll look at scan settings. For most users, we recommend using Auto Scan, which allows the machine to determine the best parameters for your scan. On AutoScan, the main variable you can adjust is scan time, which corresponds to scan quality. A faster scan will take fewer images and will give a coarser end result. A slower scan will take many more images and will give a higher resolution end result. After running a few scans, you'll start to get a better idea of how the different settings correspond to different scan qualities. A lightweight plastic part can be scanned in as little as a few minutes, but a thicker steel part might need to be scanned overnight if you need finer resolution details. Advanced users can use the manual scan screen to adjust scan parameter settings, such as beam energy, current gain, and exposure time. We also provide the option to develop repeatable scan recipes, which your team can use to automate batch scanning with the ability to ramp all the way up to production volumes. Now we're just going to go back and hit the auto scan button, which will start the scanning process. Neptune will take care of everything for you after this point. It will run the scan and upload the data to our software, which will reconstruct it into a 3D model which will be available for viewing and analysis in Voyager, our cloud-based software. We believe that industrial CT is an unparalleled inspection tool that every engineer should have access to. We're excited to see what you scan.